what I want you to do is we're going to add on to those notes that you have taken for lesson 7.4, and I want you to put at the, let's put this, that we are doing on page 485. The first one that we're going to do is number 64. I keep finding out that you guys think you have things figured out, but as soon as you have to apply what you've learned to an application problem, things just fall apart for some reason. So we're going to practice a couple of application problems together before you go to work on the homework. So let's look at number 64. We have a geometry problem, they call it. They give us the area of a rectangle that is pictured. They say its width is x plus 1 centimeters, and they want us to find its length. As I told you before, when you're taking your own notes, just writing down the information that whatever work you do and not having anything to reference it to is not very helpful. So let's draw ourselves that rectangle right in your notebooks. Because you don't get to have your book open while you're taking a quiz or a test and using your notes. So let's have something that will help us. They have the width labeled on the other side. It doesn't matter which side we label the width on. We're looking for the length, so we can call this side or the opposite side of it the length, and that's the one we're actually looking for. And what do we know about, other than this, what else do we know in this problem? You know, the area of that rectangle, don't we? Okay. So the area, let's just write it inside of it. Let's just say, what is the area of this rectangle? The area is 6x squared
Plus 11x.
plus 11x
Plus 5.
plus 5. And why did they put it in parentheses? Because of the label, right? Because and also maybe to show that it's a polynomial, but that is centimeters squared. Okay, how do we find the area of a rectangle? Length times width. So to find the area, to get that area, they took some length times some width. Well, our length is a question mark right now. Our width is x plus 1, and our area is 6x squared plus 11x plus 5. Any suggestions what you think we could do to help us find the length of this rectangle? Dylan?
Well, if you're going to find the area, you want length times width. So if you're trying to find the length, it's divide the area by width.
Okay. Do we know how to divide a trinomial, that's what the area is, by a binomial? Do we know how to do that? Have you learned that yet? Division of polynomials? You actually have done some division of polynomials, but that's when you're dividing by a monomial. The GCF of a monomial. Yeah? So we've learned how to do that, but we really haven't learned how to divide a trinomial by a binomial, so that would be very helpful to us right now. Okay, then maybe there's another thing we could try. That would work if we knew how to divide polynomials. We don't right now. What do we know how to do? That might be helpful. Factor. So if we factored the what? Area, we would have a binomial times a binomial, and one of those binomials would be the width, and one of them would be the length. And even though they already told us what the width is, it would be a good thing if after we factor it, we find out that that is one of the factors, right? Okay, so let's do that. Let's try factoring it. Let's factor so what we're going to do is we're going to factor that trinomial 6x squared plus 11x plus 5. Well, what's the first thing we always identify?
A, B, and C.
A, B, and C. So let's go ahead and get our A, B, and C identified. When A is not equal to 1,
Multiply A and C, and then
so
do
we
the diamond.
have to take the A times the C, which is 6 times 5, which is
30.
30, and they have to add up to 11. So we got to find two factors of 30 that will add up to 11. 6 and 5, okay. So what do that 6 and 5 represent again right now? Those are x's, aren't they? That's a 6x plus a 5x, and what are we gonna do with those?
We're gonna put them into the expression in place of 11x.
Yeah, this is gonna take the place of our 11x, isn't it? So we're going to rewrite our trinomial, replacing that 11x with 6x plus 5x, and we'll create for ourselves a 4-term polynomial, and we will factor by grouping, right? Okay. It's all addition, so we don't have to worry about changing any subtraction. Before we insert our parentheses, we can just insert our parentheses and go to town. Okay, factor that by grouping, you know how. And sure enough, look what happened. One of the binomial factors is our width, isn't it? So what's the other one then? Okay, so let's write that out, what we just found. So we were going to say the length of the rectangle is 6x plus 5, and our putting in parentheses is, of course, we're going to give it a label. Label centimeters. Because we said this is the what again? This is the width. Length times width. Doesn't matter which order we can multiply it. In other words, can they trade places if you say, well, we say length times width, that's width times length. Does it matter? Now, there is such a thing as polynomial division that you haven't learned how to do yet, and we'll learn that in 2 years from now in another algebra class, and that would have gotten us the same answer, 6 plus 5. But this is what we know how to do right now, right? So anybody get questions? Okay, you're going to need to allow yourself enough room if you're kind of at the bottom of this paper, you don't have a whole lot of paper, you might want to turn to the next side, because we are now going to work one more problem, which is problem number 68. We're going to start doing better jobs on the application. You might have to make it be in a room, right? Okay. Would you look at problem number 68? It's a gardening problem. Would you read that problem quickly to yourself? And of course, you know what we're going to do. We're going to make a visual in our notes. So, it's like there was this garden where, I think they used W and not X, I better change that. There is this garden that, it says the length of it was 2 times its width. So, the width is what then? What do they represent the width by? A W. Yeah. And if the length is 2 times the width, it would be 2W, right? Okay, that's the original garden. But then Rebecca decides to do what?
Add on.
Add on. Add the length and the width? Yeah. In fact, that's the length. This would be the part that we're not sure. We're looking for that. We're seeing how much was added on. And then she also wanted to add on to the width, so we're looking for how much is she going to add on to the width. What other kind of information do they give us? The area of what? The original garden or the new garden?
New garden.
That's important that we know which one, right? So the area of the new garden which would be the bigger rectangle, right? That's the newer one. The more we can put in our notes, because we don't have the book open when we're looking at these. The area of the new garden, the bigger rectangle, is what?
W squared plus 7W plus 6.
And the label? Square yard. So I'm going to shortcut that and make it yards squared. Okay? Okay, help me problem solve here. How are we going to figure out, because I think the question they asked us is how much was added on to the length and how much was added on to the width, right? How are we going to figure that out? How's that? Find the area of the whole garden and subtract from it the area of the, find the area of the old garden and subtract from the area of the new garden. Okay? So what is the area of the old garden? We would take 2W times W, which would be 2W squared, okay? And then you're saying we would subtract that from the area of the new garden? Okay. So then, if we took 2W squared away from this, what would we end up with? 7W plus 6, and those are still yards squared, aren't they? Okay. Gonna agree that that's something we could do, but now tell me, how's that gonna help us find our question marks? How are we gonna think? What do we do now then? Scott?
I've been, what if we find the length and the width from the area that we have of the bigger garden, and then find the length and width and subtract that from the length and width of the smaller garden, and then get our answer for.
So you're suggesting we maybe do the same thing we did in the last one, factor our area?
Mm-hmm.
Because are we kind of stuck here? We don't know what to do here with that 7W plus 6. Anybody know what to do with that? Because what that is really representing right there is that's representing all of this. Do we know? Okay, so this is 7W plus 6 yards squared. Anybody know what we can do with that? Okay, so sometimes we go down a path and we're like, and then we get stuck and we're like, oh, I don't know what to do now. So then we can always try something else. We can say, John suggested, how about we just factor our area again and see what happens. So let's factor our 2W squared plus 7W plus 6. So at the top of our, we have to do A equals, B equals, and C equals. Taylor, what's A? 2, not W. What's B? 7, and what's C? 6. Okay, that means then that what's going to be up in the upper part of our
2 and 6.
2 times 6, which is 12. We need 12 up here, and a 7 here.
3 and 4.
3 and 4. 3 times 4 is 12. 3 plus 4 is 7. That means we have 3W plus 4W, right? We just took that 7W and shared it. We said, we're going to rename it. We're going to call it 3W plus 4W. So now we will take our polynomial, trinomial, and replace the middle term with our findings. And it's straight addition, so we can insert our parentheses and go to work factoring by grouping. What's the GCF of the first group? What's the W? And what's the resulting factor? 2W plus 3. That's the first group. What's the second group's GCF? 2. And the result is 2W plus 3. Well, good news, we have two binomial factors that match each other. That's always a good thing. So now we say The GCF is 2W plus 3, that's one of my factors. And what's the other factor?
W plus 2.
W plus 2. Oh. Isn't that looking pretty good? So how are you going to answer this question? Because this is on a standardized test, there's multiple choice answers, and one of the answers is the length was increased by 2W plus 3, and the width was increased by W plus 2. Is that the answer you're going for? Yes. Anybody think there might be another answer there that you might be wanting to consider?
W plus 2 times, or wait, what, isn't the question asking?
Allison? So basically, you guys will be, you kind of want to do a subtraction problem, which we can do. This, didn't we just find the length of the whole new garden? So remember, because this was the area of the red rectangle I have up there right now? So when we found those factors, we are actually saying that this is the length, and this is the width. But the question wasn't, what's the new length and what's the new width? What was the question? How much did it increase by? Don't make this very hard. The length before was 2W. What did it increase by? 3. The width was W before. What did it increase by? 2. Okay, let's write that out. Okay. And trust me, one of the multiple choice answers, and probably it'd be A or B, and then the answer that we really get, it would be one of the others, because they're going to make sure that you process properly. The length was increased by 3 what? Yards. And the width was increased by, what did we say? And the width by 2 yards. So you gotta be really careful with these application ones, especially on standardized multiple choice tests. I guarantee you that one of the multiple choice answers would be 2W plus 3 and W plus 2. And then another answer would be the length was increased by 3 and the width was increased by 2. And I'm going to guarantee you this too, that because they go in order A, B, C, D, 2W plus 3 and W plus 2 would be one of those first ones, because what does your eye do? It looks for the one that you got, the answer you got, and what does it do? You're like, I'm feeling successful, I got the answer that's in the answer bank, and you go for that one. And you don't take enough time to think critically and say, was that what they were really asking me for? So that's why we don't do so well on application problems. Especially when there's a multiple choice bank to choose answers from. We're just happy if something we got is in that answer bank and we say, good, I got it. Okay? Okay, we'll be done.